Hello, in the past couple of videos we have been looking at how to manipulate graphs. In today's video we will be focusing on how to manipulate a function to horizontally shift in the positive or the negative direction. If you have the function f of x and you want to shift it to the left or to the right, all you need to do is add or subtract a constant from the x value. So if you have your function f of x equals, let's say, x squared, and we want to shift to the left or to the right, all we need to do is plug in a value x plus or minus that constant into this equation, which would form x plus or minus c squared. This is different than if we were to have the function f of x equals x squared plus c, because this would move the graph vertically up and down. However, for horizontal shifts, we need to actually focus on that x value itself within the function versus outside of the function. I do want to note that movement and horizontal shifts are opposite than what you might think. So if you add a value to the x, you will actually move the graph to the left in the negative direction. Whereas if you subtract a value from x, you will shift the graph to the right. And so if you have f of x minus c, that's going to shift the whole graph to the right. Where if you had f of x plus c, that's going to shift the graph to the left. So just be careful when you are wanting to shift a graph to the left or to the right. Taking our function that we have up there, x squared, if we graph that, then the original x squared is going to be here at the origin, and we're going to go up 1 over 1, to the left 1, up 1. We'll have points there, and we'll connect those. So say we wanted to move the graph to the left 2, then all we would need to do is take the original function, f of x, that x needs to get a 2 added to it, into our function x squared, which then would become x plus 2 squared. When we solve for this, we can plug in 0. If we plug in 0, then we see that we're going to be left with 4. If we plug in negative 2, then we're going to be left with 0, so that would go there. If we plug in negative 3, we're going to be left with 1, so that's going to go there. If we plug in a negative 1, we're going to be left with 1 again, so that's going to go here. We can connect these dots here, and we see that the graph of x squared is the black, and we see that the graph of x plus 2 squared is the graph in the yellow. And we see that they are identical. It's just the graph has been shifted 2 units to the left because we've added 2 to our x value. Okay, now that we understand the rules, let's look at a couple examples. Our next problem gives us the function f of x equals x minus 1 multiplied by x plus 1. And the question asks us to find a new function that has the original function shifted to the right by 3 units. In other words, take this function that they've given us and shift it to the right 3 units. And what is the equation of that new function? And then it asks us to graph both the original function and the new function that we found. For this first function, we do have f of x equals, if we multiply these factors together, that's going to give us x squared minus 1. We know by our rule of horizontal shifting that if we take the function x and we want to shift it to the right 3 units, so therefore we need to subtract 3, and that's going to move it to the right 3 units. So if we subtract 3 from our function, then this is really going to be equal to x minus 3 squared minus 1. So now what we want to do is graph these functions. So on the same graph, we can draw this out. I'll draw our original function in black, and then I will draw our horizontal shifting function in yellow. But for our first point, we get 0, -1. And if you were unsure if this is the vertex, I will link a video in the description below on how you can find vertex of parabolas. But in this case, we do know that 0, 1 is going to be our vertex. If we plug in the value of 1, then we're going to get 0. If we plug in a value of -1, we're also going to get 0. So we will connect these points, and this is the graph to x squared minus 1. If you are familiar with vertical shifts, we do see that we have our original function x squared, and then if we subtract a constant from that, that's going to shift it up or down. If you need a refresher on that, I will also link a video in the description below. However, looking at our altered function, now we have x minus 3. With that, we can graph this as well. Let's add a couple points just in case. Since we're assuming that we have shifted it 3 points to the right, then if we go to 0, 3 as our first point, so x equals 3, then we're going to get 0 squared and then minus 1, which is -1. So 1, 2, 3 over 3 at 1. If we go to 4, then we do 4 minus 3, which is 1. 1 squared is 1, 1 minus 1. And if we do 2, then that's 2 minus 3, which is -1. -1 squared is 1. 1 minus 1. So then we see, by connecting these points, that this graph is in fact the same as our x squared minus 1, our original function. However, it has shifted 3 units to the right. And if you want, you can check that all points on the graph are exactly 3 units over. And there you go. Now you know how to manipulate and shift a graph horizontally, whether that be to the left or to the right. Again, what you need to do is you need to take the function with respect to x and manipulate that. So if you want to move to the right, then you actually need to subtract, or if you want to move to the left, then you would want to add. Remember, when wanting to shift horizontally, it's not exactly what you would expect, where if you add, you're going to go to the right, or if you subtract, you go to the left. You have to flip-flop them. And again, if you want to go to the right, you need to subtract, and if you want to go to the left, you need to add. If you have any questions, please leave them in the comments below. If you learned something, please like and subscribe, and we'll see you next time.